So today our lecture is called Types of Chemical Reactions. And if you guys notice, it's part 1. The reason why is because we're going to do part 2 the next time that we meet. Basically, what we're going to be doing now is we're going to be taking these chemical reactions that we've learned how to do stoichiometry with, and we're going to figure out what type of reaction it is. Okay, there's 5 different types. We're going to go over 3 of the easy ones today, and then we'll save the next 2, a little bit trickier, for the next time that we meet. So you guys don't need to copy all this down. I'll tell you the parts you have to write down, and then some things that might help, but don't feel pressure to copy all of this, okay? So the first thing that you guys have to write down is the name of the type of reaction, and the first type of reaction is called a synthesis reaction. So just make sure you jot this down somewhere. Okay, the first type of reaction is called a synthesis reaction. And there's a definition right here, but basically what you're doing is you're combining simple compounds. So here we have 2 different chemicals and they are combining to form another one. Okay, so that's an easy way to get a synthesis. Next. So again, synthesis is when you have 2 or more different chemicals and they combine to make a bigger one. Okay, so for those of you that like Dragon Ball Z, it's like a fusion. They do a fusion dance and they make Gogeta.
Oh my god.
There you
the
go.
best character in the series.
Gogeta?
No.
Oh.
But he still will.
So again, you get 2 or more individual things and they combine to make a bigger one. Okay. We got some examples right here. You guys don't need to write the examples, just there for you to see. But here we got H2 and O2 and they form H2O.
Oh my god.
Okay? I know, it's amazing. We got H2 and N2 and they form NH3. So you guys can kind of see how the chemicals are combining to form a bigger one. Okay? No, you don't need to write these examples down. They're there for you on Canvas already. Just write down the name of the type of reaction, synthesis. And if you want to write a definition, you can. Yeah, what up in here?
I'm sorry if you covered this, but why specifically is the N before the H, and how did you get N or H3?
Oh, it's just the formula for the chemical. You could also write it like this, H3N. It doesn't matter. It's just I put N first.
Okay.
Yeah, so the order doesn't matter at all. It's just written like that.
Okay.
Yeah, good question, though. So if you guys want a, I guess, a more relatable way to understand it, a synthesis reaction is like this right here. There's a guy. He sees a pretty lady. And then they start dancing, so they're together now. And so they form something more complex than they were before. Yes, that's why it's called chemistry.
Oh.
Okay. All right, any questions on the first type of reaction? Pretty simple, right? Just simple things, they combine. Fusion. Okay, let's move on to the second type. The second type is the opposite of synthesis. It's called decomposition, and it's where you get one thing and it breaks down into multiple things. So easy way to identify decomposition. You guys only need to write down the name, but for a decomposition reaction, there's going to be only one chemical on the left side, and then on the right side, you're going to have more than one chemical. Okay, so if you ever see this kind of reaction, where there's one chemical on the left side, but multiple on the right side, that's a decomposition reaction. You got some examples right there. Okay, notice they all have only one thing on the left, but they have multiple things on the right. Okay. Yeah, what's up? Oh, let me write it there for you. It was synthesis. I'll write it for you right now. First one was synthesis. Okay, so again, synthesis or decomposition is where you have one chemical and it breaks down into more than one. So opposite of synthesis, and so the example is basically going to be the opposite as well. Synthesis is where they start dating, but then decomposition is when they break up. He said something wrong. Okay. All right, any questions on synthesis and decomposition? Again, you guys don't need to copy all this down. These examples are all there for you. Just understand synthesis is coming together. Decomposition is breaking apart. Okay. Yeah, we have one more for today. Yeah. Okay, let's move on to the last type of chemical reaction that we're going to look at today. The last type is kind of like synthesis, but it's a special type of synthesis, okay? It's called combustion, okay? And you guys might have heard this term before because combustion is like explosions, fire. Those are all combustion reactions. Okay. So the last type we're going to go over today is combustion. And combustion is very easy to identify because all you need to do is if you see O2 gas on the left side with something else. So if there's two things on the left side and one of them is O2, you know that it's going to be combustion. Okay. Okay, because something is going to react with oxygen. That's why fire needs oxygen in order to burn. It's because it's a combustion reaction. It needs oxygen as a fuel. Okay, so if you guys notice on the examples, there's O2 on the left side, and there's something else that's reacting with O2. So that's how you can identify a combustion reaction. There's O2 on the left side, and there's something else with it. Okay, that's pretty much it for today. That's all the new information we're going to go over. No, there's no cartoon for this one. Actually, I'll draw one for you. There's a bomb. Okay, there you go. That's your cartoon. Yes. Okay. Any questions on the three types of reactions we went through today? You guys think you could identify some on your own?
So combustion is just on the left side, it has oxygen in it, and on the right side, so it has a forms of molecules.
Yeah, it forms different types of molecules. Yeah.
Okay.
That's it. Okay, so we're gonna do one example problem together before I let you guys start on your assignment, and this is what your assignment problems are gonna look like. We're gonna be doing stoichiometry again, so we're actually never gonna stop doing stoic.
Yes.
So there's stoichiometry for the second part, but on your assignment today, you're also gonna have to tell me what type of reaction it is. So I want you guys to take a look at this chemical equation right here, and I want you guys to just write down on your paper: is it a synthesis reaction? Is it decomposition? Or is it a combustion reaction? Okay, so just look at the reaction right here. Look at your notes. Try to figure out which one of the three it is, and just write that down. And that's going to be the answer for part A. Okay, yeah. Oh, this is the sample. Oh, the sample reaction. Yeah. Yeah. This one right here. Okay, so yeah, take a look at it. You can talk with the person next. I'll give you 30 seconds to figure out what type of reaction this is, and then we'll go over it together.
Mr. Question. Is it synthesis reaction could have oxygen in your face?
It can.
I know you did a trick question. Yeah.
This is kind of a trick, yeah.
I'm gonna say combustion.
Alrighty, guys. So let's go over part A. So for this one, if you guys notice, it's two things becoming one thing. So that kind of looks like a synthesis reaction, right? But remember, we said combustion is a type of synthesis. It's where you have O2 as one of the reactants, and you have something else. So since it has O2 and something else, this is going to be a combustion reaction. Okay.
Yeah.
So this is going to be a combustion reaction. Okay. So if you guys put synthesis, it's okay. You're on the right track. It's just more specifically a combustion reaction. Okay. Okay, and then for part B, we're gonna be doing what we've been doing for the past like 2 months now. We're gonna be doing some stoichiometry. It's been a while since we did a problem like this, 2 weeks, I think. So I'm gonna go over how to do it. So if you guys know how to do this, just kind of zone me out for a bit. You could try solving it to see if you're still good. But yeah, I'm gonna go over the stoic problem. So the first thing you want to do is you want to balance, but we already balanced it, right? There's numbers in front, so we can skip that. The second step is you want to find the molar mass of the important chemicals. So if you guys notice, our starting number is 5 grams of Mg. So this is going to be an important chemical. It says that O2 is excess, so we can kind of cross it out. We don't really care about O2. It's not going to make a difference. And then we're looking for mass of MgO. And so this is what we're going to end up with. So these are the 2 important chemicals in this problem. So I'll give you guys about a minute. I want you guys to look at your periodic tables and see if you can get the molar mass of Mg and MgO. Let's take a second to do that. Because of that one mistake. It's okay, Alan. You'll be fine. Take about 40 seconds. Find the molar mass of those 2 important chemicals. Okay, maybe 15 more seconds to finish that up. All right, guys, let's go over the molar mass, see if you guys got it. So our first important chemical is Mg. So we're going to go on the periodic table and look up Mg, which is 24.3. So we're going to write 24.3. Okay, so the molar mass of Mg is 24.3 grams per mole. Okay, the next one is MgO. So we need to add an Mg, which we said was 24.3. And we got to combine that with oxygen, which if we look on the periodic table is 16. So we're going to 24.3 plus 16, which is going to give us 40.3 grams per mole. So there you go. Those are your 2 molar masses. Okay. Thank you. I'm doing my best. Okay. Last step is we want to do the fractions and the dimensional analysis. So what we're going to do is we're going to write down our starting number, which is 5 grams of Mg. And then we're going to set up 3 fractions like we normally do. On the tops, we're going to do gmg, so grams, moles, moles, grams. We said that the first 2 fractions have to be about the same chemical, and the last 2 fractions are about the same chemical. So the first 2 are about Mg, and then the last 2 are going to be about MgO. So again, this is pretty much review. If you guys are pretty comfortable with Stoic, you're actually in pretty good shape for the rest of the year, just because we're just going to be doing the same thing over and over. We're just going to be adding little things like this on top of it. Okay. And now that more people are back, we can we actually have a lab coming up next week. Okay, so we're going to be putting this in real world application. All right. So just a reminder that the first fraction, you're going to get the numbers from the molar mass. Second fraction, you're going to get the numbers from the balanced equation. And the last fraction, you're going to get the numbers from the molar mass. So using that information, we can just plug in what we have to into the fractions. Yeah.
So basically, it's just like what we did before, except now we also have to identify what chemical reaction.
Exactly, exactly. You're just adding one little thing on top. Yeah, one tiny thing. It's going to be more than that later, though.
Oh, no.
Okay, we're going to put grams of Mg on the bottom. You're going to use the molar mass of Mg, which we said was 24.3. So 24.3 grams and 1 on the top, and the Mg will cancel out. Okay. Next, we're going to put moles of Mg on the bottom. The numbers come from the balanced equation. There's a 2 in front of Mg, so we put a 2, and a 2 in front of MgO, so another 1. That will let us cancel out moles, and you can also cancel out the 2's. And then last but not least, we're going to put moles of MgO on the bottom. You're going to get the numbers from the molar mass of MgO, which we said was 40.3, and it's going to be 1 on the bottom. So these cancel out, and there you go. We have everything that we need to solve this problem. Okay, so we just plug and chug into the calculator. Numbers on the top we multiply, numbers on the bottom we divide. So 5 divided by 24.3 times 40.3. That'll give us a final answer of 8.292 grams of MgO. All right, and there you go. That's going to be your answer. If you were able to get that on your own, or if you're comfortable with it, you're in good shape. Okay, now before you guys start on your assignment, one thing I do want to clarify before you guys start, because I got a lot of questions last class, is if you ever see something asking about products or reactants, just remember that reactants are the chemicals that are on the left side of the arrow, and then products are the chemicals that are on the right side of the arrow. Okay, so if you guys don't know that, make sure you guys jot that down somewhere, because it'll be very helpful with the first 2 problems on your assignment today. I just wanted to give you guys a quick reminder of it, just so you guys know what the question is asking. Okay, reactants are all the chemicals on the left side. Products are all the chemicals on the right side. Okay. Alrighty, I'll leave this up here so that you guys have something to look at as a reference for the rest of your assignment. Let me know if you have any questions or if you guys want to check your answers, but good luck on the assignment, guys.
Oh, assignment's okay.